For this lesson, we're going to be looking at word problems using quadratic equations. And we're going to be breaking them down into three different categories. So we've done most of these before, but I want to go through all of these types of examples beginning to end together so that you can see all of the steps. So the first one here is the path of an object. And we've actually done a lot of path of an object questions. So hopefully this one makes a lot of sense when we go through it together. So the general formula, h equals -1/2 gt squared plus v naught t plus h naught, can be used to model the height of a projectile. And this general equation, it's a little confusing because there are so many variables, is actually an equation that is used in physics to model the height of any sort of projectile. So for our course, I would never ask you to develop your own equation for the height of a projectile. However, it is very useful to know how these concepts would be used in the real world. And stuff with projectile motion is actually used all the time, so there are real world applications of this stuff. So in this specific general equation, g, this little g here, represents the acceleration due to gravity, which is always 9.8 meters per second squared and well, on Earth. And then V naught, so that little zero is referred to as naught. And when we put the little zero there, it's always telling us it's an initial value of something. So in this case, V naught is the initial velocity in meters per second. And then H naught is the initial height. So now, for our specific example that we're going to be looking at, a toy rocket is launched upward at 60 meters per second from the top of a 3-meter tall platform, and its path now follows this equation. So all I've done is instead of writing a g, I subbed in 9.8 meters per second squared because that is acceleration due to gravity on Earth. I subbed in 60 because that was our initial velocity, and I subbed in 3 because that was our initial height at the time the rocket took off. So you won't have to do that part, but again, it's very useful just to see how this stuff is used in practice. So our question here is how long would the rocket take to fall to Earth, rounded to the nearest hundredth of a second? So our rocket looks something like this. So I always like to start with a little diagram just to give yourself an idea of what's going on. So it says that my rocket starts at a height of 3. So I'm just going to put that little height of 3 here. And then my rocket takes off from there and then comes back down to the ground at some point. So my graph's going to look something like this. And although we don't really count this part because it's a negative time, their graph technically does continue on into the negative spots. So just be mindful of that as we move forward. So we're looking for how long the rocket would take to fall to Earth. So we're looking for my 0 over there. We're looking for when it hits the ground again. So we're just going to sub in h equals 0. So we'll have 0 equals 1/2 times 9.8 t squared plus 60t plus 3. And I'm just going to simplify that 1/2 times 9.8. -4.9 t squared plus 60t plus 3. So now we need to solve for t, and there are a few important clues here that are telling us how to solve it. The first one is that we have decimals in our question. So typically when we have decimals in our equation, it's unlikely that we're going to be able to factor this thing. So that right there is a clue that we're going to use the quadratic formula. The second clue is that the question says to round to the nearest hundredth. So if we're rounding, again, it means we're using the quadratic formula. So we're just going to label our A, B, and our C. And then we can fill them into the equation. So our T is going to be equal to -b plus or minus the square root of b squared minus 4 times A times C all over to a, and I'm going to start by simplifying the stuff under the square root sign. So t is equal to negative 60 plus or minus the square root of 3,658.8, and all of that is over negative 9.8. And now I'm just going to separate it into my addition equation and my subtraction one. So we break that up. So there's my addition one. I have my subtraction one as well. And then I can just simplify those. So once I simplify those in my calculator, I will get negative 0.05, and I will get 12.29. So if I go back and look up at my little sketch here, this is going to be 12.29, and this one over here is going to be negative 0.05. So now if I look at my sketch, I know that my rocket hits the ground after 12.29 seconds. So that's our first example. Our next question asks, over what time interval is the height of the toy rocket greater than 150 meters? So if I go back to my little sketch here, I'm looking at 150 meters, and I want to figure out for how long it is above the pink line there. So that's what I'm going to be trying to figure out. So what we first need to figure out is when it hits 150 meters. So that's the first thing that we'll do. So let's sub in 150 meters for h. So that will give me 150 equals negative 4.9 t squared plus 60t plus 3. And now to solve for t, the first thing I need is I need this thing to equal 0. All of this only works if our equation equals 0. So let's move that 150 over to the other side. And now I need to solve for t. Similar to before, because I have decimals in my question, I am most likely using the quadratic formula. And then it also is giving me a clue in the question by telling me to round, so that's another sign that I should be using the quadratic formula. So we'll identify our A, our B, and our C, and we can sub all of those into the equation. So once I have it all into the equation, I'm going to simplify all of that stuff underneath the square root sign. And that will give me 718.8 all over negative 9.8. And now I can separate my equation into the two equations. So this side will be the addition one, so t equals negative 60 plus root 718.8 all over negative 9.8. And this side will be the subtraction one. So negative 60 subtract 718.8 all over negative 9.8. And when I put those two in my calculator, I will get t equals 3.39. and t equals 8.86. So now that I have those two times, let's go and put them onto our sketch. So what that's telling me is that here is 3.39, and this spot here is 8.86. So now we need to figure out how long was the rocket above that 150. So it was above that 150 from 3.39 all the way to 8.86. So in order to find out how long that time was, we're just going to do 8.86 minus 3.39. And that was 5.47 seconds. And although this question only asks for the time interval, a lot of them will ask you for how long it's above that height. So just so we've covered all of our bases and we know how to do all of it. So now my therefore statement will say, therefore, the rocket is above 150 from 3.39 seconds to 8.86 seconds for a total of 5.4 seconds. So that's our first kind of problem. And for these problems, again, highly recommend you draw a sketch. It makes a world of difference. And then once you have your sketch, it helps you to identify the points you're looking for. So that's our first example. The second kind of question we're going to be doing are consecutive number questions. And these are ones that people find a little bit challenging. So we're going to go through the setup nice and slow. Once we get the setup, everybody seems to be okay. It's just that initial setup that's hard. So we're going to look for two consecutive even numbers that product is 5,624. So we're going to start by making some let statements. So we're looking for two numbers. So I'm just going to write let x represent the first number and because we're looking for consistent even integers, if I had one even integer, to get to the next one, I'm going to add 2. So for example, to get from 2 to 4, I would add 2. To get from 4 to 6, I would add 2. So we can let x plus 2 represent the second number. So the other piece of information we're given is that the product of these two numbers is 5,624. So we know that their product is always equal to two numbers multiplied by each other. Take the first one and we'll multiply it by the second one. And then we're also given that their product is equal to 5,624. So now let's simplify this. I'm going to multiply in that x over there. And then I'm going to move over this 5,624 because my equation needs to be equal to 0 to solve it. And now I need to solve for x. So because I have whole numbers, this is a clue that I can factor it. If you're unable to factor it and you're finding it challenging to find your two numbers, that's absolutely okay. You can use the quadratic formula and you'll get the same answer. But you can actually factor this. So we need two numbers that add to 2 and two numbers that multiply to negative 5,624. And when you find those two numbers, we will have 76 and negative 74. So we can rewrite that as x plus 76, x minus 74, like that. And now we can just solve for our x's. So I'm just saying both brackets equal to 0. So I get x equals negative 76 and x equals positive 74. Okay, so these are our two options for that x in our let statements. So I'm just going to highlight them different colors so that you can see what I'm going to do in the next part. So x represented our first number. So we need to find the second number that goes with both of these options. So for our first number of negative 76, our second number was equal to x plus 2. So in this case, we had negative 76 plus 2, so I will get negative 74. So my first pair of numbers is negative 76 and negative 74, which makes sense. Those are two consecutive even numbers, and their product is 5,624. And now I need to find the second one. So for my green answer here, my second number is also x plus 2. So in this case, x is 74 plus 2, so I will get 76. So that's giving me my second combo of numbers, which would be 74 and 76. And those are consecutive even numbers, so that's good. And also, their product is 5,624. So now I can just put my little therefore statement. So therefore, the numbers are negative 76 and negative 74, or my other option is 74 and 76. So that's our second kind of question. Most people find this one the most challenging to set up. So if you're feeling that way, don't stress, just keep practicing. And I would suggest maybe using some different colors because sometimes that helps people as well. Okay, our third and final one for today are right angled triangle questions. So for this question, one leg of a right triangle is 1 centimeter longer than the other leg, and then the length of our hypotenuse is 9 centimeters greater than the shorter leg. So find the length of the three sides. So I'm going to start by writing a let statement, and we want to write all of our sides in comparison to one of them. So I'm going to let x represent the length of the shortest side. My next step is I'm going to draw a quick diagram to help organize myself. So something along these lines, like this. All right, so there's our little diagram here. And we said that x is the shortest side, so we can put that right here. The next piece of information I'm given in the equation is that one leg is 1 centimeter longer than the other. So I know that this side must be x plus 1. And then I know that the length of the hypotenuse is 9 centimeters greater than the shorter leg. So x plus 9. So now, because I have a right angled triangle and I have some side lengths, that's a clue that I should be using my Pythagorean theorem. So just as a reminder, our Pythagorean theorem is a squared plus b squared equals c squared. And when I'm using the Pythagorean theorem, it doesn't matter which side you make A and which one you make B. The only thing that matters is that our hypotenuse is C. So that one across from our right angle, that one has to be C no matter what. So let's sub in some values. So side A is x, and that squared, plus x plus 1 squared equals x plus 9 squared. And now I'm going to simplify these. So we have x squared plus this whole thing simplifies to x squared plus 2x plus 1 because it is a perfect square trinomial. If you need practice with that, you can absolutely expand both of them out. And same deal over here. We have x squared plus 18x plus 81, like that. And now I'm just going to collect some like terms. So on this side, I have 2x squared plus 2x plus 1, x squared plus 18x plus 81. Now, in order to solve for x here, my equation has to be equal to 0. So I am just going to move everything from the left side over to the right side. If you want to move it over to the other side, that's fine too. So we'll have 0 equals x squared plus 18x plus 81 minus 2x squared minus 2x minus 1. And now I'm just going to collect some like terms. So I'll have negative x squared plus 16x plus 80, like this. And now I'm going to solve for x. So I'm going to try by factoring, because you can factor this one, but if you weren't sure and you ended up using the quadratic formula, it would be absolutely fine and you would get the exact same answer. So the first thing I do when I'm factoring is I common factor. And because I have a negative in front of that x, I need to factor that out. And now I'm just going to factor. So I need two numbers that add to negative 16 and two numbers that multiply to negative 80. And in this case, those numbers are going to be negative 20 and 4. So negative 20 and 4, negative 20 and 4. And now we need to multiply out that negative, so let's get rid of that. Sorry, divide out. And we're left with 0 equals x minus 20, x plus 4. And now we can set each of those brackets equal to 0. So we'll have x minus 20 equals 0. So that gives us x equals 20. And then we have x plus 4 equals 0. So that gives us x equals negative 4. Now we have two answers here. But because this is a real world problem, we need to look at our answers and see if both of those make sense. So because I'm dealing with side lengths here, I can't have a negative side length. That doesn't make any sense. So that's why this one gets crossed out, because we're looking at side lengths and real world stuff. So what that means is my x is equal to 20. So let's figure out what our side lengths are. So this side, x is equal to 20. So we can just fill that in. The next one over here is 20 plus 1. So that side is equal to 21. And then our last one is equal to 20 plus 9. So our last side is equal to 29 centimeters. So we can say, therefore, the side lengths are 20 centimeters, 21 centimeters, and 29 centimeters. And that's our last kind of problem. So the solutions for all of this have been posted, and so have the solutions to the homework problems, so you can go through them and keep practicing.